record on this computer. So did you write you rewritten Next using Fastify?
Yeah, sorry, you're asking me if
You rewritten Next using Fastify. Is that correct?
Yes, that's currently my project. I'm going to give a little taste of it towards the end of this session.
Oh my God, that's great news. Amazing.
Yeah, it's been in the works for over a year now. So yeah, I started playing with Fastify and getting Nux to run, but I realized that running Fastify Nux on top of Fastify, there's a lot of overhead because you have Fastify and you can leverage a lot of the Fastify goodies, but you're still running an Express middleware engine and a lot of middleware functions serially, and you're loading all of that arbitrary Nux runtime. And the same is true for Next.js or any of the super mega frameworks out there, like the new Remix one. They are huge. They deliver a lot of good developer experience, but they are huge. So as a minimalist, this always bothered me. I wanted to get a solution that stayed minimal and focuses on the absolute minimal building blocks for delivering an application like that. So I'm really excited to do this talk because this is the talk, this is the session / workshop that I wanted to have found 5 years ago when I was starting up with this stuff, because 5 years ago it was black magic. Like when I first realized, oh my God, I can render client-side JavaScript on the server, pre-deliver the markup, and the whole use of universal JavaScript concept clicked. Now there was very few starting pointers, very few pointers back then. So I'm hoping that in this session, I'm going to be able to really pass along this knowledge about these core building blocks, what Nux.js, Next.js, and Remix share in common.
Sorry, do Next and Remix use Fastify?
No, they are using the middleware.
So maybe after your workshop, they do use. Might change their mind.
Well, let's see. Let's see how it goes.
Okay, we're gonna write history here then. Okay, we are ready, and you're now on
Should I do
Twitter.
the intro again?
Maybe yeah. Let's do it. You are also on Twitter.
Okay.
You can retweet that so people can watch it there as well. And yeah, I'm so looking forward to hear from you and learn. And I'm gonna be the host, so anybody else that comes now, I'm gonna getting them into the workshop. Thank you very much for doing this for us. It's a great honor.
Likewise, thank you so much. All right, so let me do the quick intro. I'll do a quick intro about myself again. So I wrote a Flash 5 ActionScript book 18 years ago. Fun fact, I was in love with Python for 10 years. I dabbled with Go, Kubernetes, and the DevOps craft. I jumped into full stack JavaScript for no reason. Fell madly in love with Vue.js, became a core contributor to Nux.js. Then I dropped out of the Nux team to focus on Fastify stuff. And I started as an engineering manager at Nearform last year. I'm still doing a lot of open source work. So, all right, let's jump into talking about SSR. SSR, server-side rendering, comprises various techniques involved in running client-side JavaScript on the server in order to pre-generate markup for delivery prior to page load. So that's my definition. If you look for it, you're going to find several other definitions, but I think this captures the gist of it. So why do we care about SSR? It's not just about search engines. It's not just about ensuring that the Google gets the fully rendered version of your app as opposed to a JavaScript bundle. SSR improves user experience because users don't have to wait for CPU-bound JavaScript to run on the client before they can see anything. Those we get. Several metrics are improved, such as first paint, first contentful paint, time to interactive. These are the metrics that you see when you're benchmarking your site in Lighthouse. So There are no extra round trips for data fetching and templating. You can use JavaScript universally for backend and the front end. And a lot of the JavaScript can stay on the server. You don't need to deliver all of that to the client. Static site generation becomes easier. So there's a great piece by Eddie Osmani and Jason Miller on the Google developer site that I like to recommend. It really goes into a lot of the details about these techniques. So we also need to ask ourselves, why not SSR? SSR is ideal for dynamic data-dependent applications. There is an added cost of running live application servers. So if you should avoid it if you're just able to host fully, get your app going, has an SPA, and you can back it with an API that can be more cost effective. You should avoid it if you can just pre-generate everything, just deliver static files, of course. And you can also consider running hybrid setups where you do SSR for some pages and you do static delivery for others. So I set up a repository. For your convenience, I'm going to share this on the chat here. So in this repository, you're going to find all of the examples that we're going to go through. And it's going to be 7 examples, and it's basically an evolution of the same app, starting with a very basic Fastify server, and then getting to the new technology that we're building. So you can go ahead if you want to participate hands-on and see things running, and also take part in a couple of exercises I have for you at the end. Go ahead and clone that repository. And then you follow these instructions, go into the examples folder, npm install, and then npx zx install.mjs. And that should take care of installing the dependencies for all the examples. All right, so there's a lot that I want to cover. So I'm gonna try and speed up through the first couple of examples, because they're really basic, just building the foundation so I can explain these concepts. So let's build a really simple to-do list, a really simple one. Doesn't do anything, just gets displayed. So it's like doing JavaScript like it's 2012 for a bit, because this example has none of the modern JavaScript stuff that we are now used to. So you can see that example in the example/to-do1 folder. You're going to need node 16 to run this, and you can see it rendering on localhost 3000. So like I said, for this first couple of examples, I'm going to go through it really fast. And I have all the snippets on the screen, so you can just pay attention and not worry about running it now. All right, so in this example, we have a template that's client.html. That's just AJS, which is a JavaScript templating language for Node.js. We display a list, and we have a little Fastify server that basically loads the template, turns it into a function, and then you have a little to-do list, and we deliver that to-do list to the client. There we have it. So SSR is a bit of a misnomer. What we did in this first example is basically server-side rendering markup, but this is not the SSR we're talking about today. We're still using AJS on the server, and we can run that on the client. We basically get that markup on the client. We're not running client-side JavaScript on the server yet to generate that markup. So, but before we do a little bit of real SSR, let's get this example a bit fancier. Let's add an input, and let's make that input send some data to the server via AJAX with a JSON request. The user should see the item added immediately. But if the page is refreshed, any items previously added should still load. So this is example/to-do2. You should be able to run that locally as well. And like I said, this is one of the examples I'm going to try and speed through because it's foundational. It's just trying to build a case for what we're building next. So in this example, we change our template to add an add button. and an input field. And then we add a bit of JavaScript, horrific manual JavaScript that sets up a click listener, picks up the value from the input, generates a JSON request for the /add JSON endpoint, API endpoint. And if we get a successful response from the server, we manually create a new list item and append it to the DOM. So this is what I meant when I talked about let's make JavaScript like it's over 10 years ago. So that also that's also accompanied by one extra endpoint on the server that basically takes the payload we're sending and adds to the to-do list variable. So this way we can update the server's live to-do list array when we update it to the client. Of course, in a real application, that would be a database. All right, so some key considerations. The code that generates the markup can only run on the server, and we have to manually update the DOM with new data. So time to do some real SSR for client JavaScript code. In the third example, this is where things start to get interesting in terms of breaking down the building blocks and concepts that make these SSR hybrid applications possible. So in this example, I use Happy DOM, which is a testing library, but I'm using this example to demonstrate SSR. So what Happy DOM does, it makes the window and document objects that you have on the browser available for operation on the server. So you can take a snippet of client-side code and run that on the server and still get a modified HTML snippet. So you can use that for doing some real SSR, so to speak. So in this example, we drop the AJS templates in favor of DOM flavored JavaScript to generate the markup. We do model-based rendering of the to-do list. So instead of manually creating a list item and adding the fragment, we're gonna have a function that whenever we have the entire data set updated, then it generates everything based on that piece of data instead of trying to manually add items to the list. We're gonna prevent it from rendering twice on first load. This is something that frameworks take care of for you. And we're gonna do all of that sharing a bit of JavaScript code between the client and the server. And what I mean by that is that we're gonna have a piece of code that runs universally. It runs on the server to generate the markup that the user is gonna get on first request. And it can also stay working on the client if the user uses the input field to add more items. So you get the pre-rendered markup from the server, the actual SSR, and when the application loads on the browser, it stays working as a single page application. So you can see that in the examples/to-do tree folder. You can start the server and play around if you want. I'm gonna go over the changes, the concepts through snippets on the screen for this example. By the way, if anyone wants to interrupt me at any time to make a question, go for it, no problems. Okay, so in this third example, the difference between and like I said, this is an evolving example. We started with something really simple, just display the list. And then in the second iteration, we add a little input and an add button. And in the third iteration, we're gonna do all of those things I just said. So we begin by splitting client HTML into the client only bootstrap script. So this is a snippet of code that's delivered to the client to get it booted. And we're gonna have a piece of code, client.js. This is the shared module. So this function right here, it's going to work. It's going to generate that markup. It's going to work on the server. And when we deliver that piece of code to the client, we can also run that on the client. So this is, in essence, isomorphic JavaScript. So this is what you get out of the box when you use a framework like Next.js and Nuxt.js or Remix. You get, and of course, I'm talking about the underlying frameworks, Vue and React. You get this kind of this isomorphic nature to the rendering, you get that for free because these frameworks can run on the client and on the server. They provide functions that do that for you. So in this iteration, we have this change and we have this function add event listeners, which basically registers the button listener code. And the server code, the bootstrap code, we now have an extra endpoint for delivering that client.js file. And you can see here that we're using the render function from the client module on the server. So this is what gets us the server-side rendered markup. And this is why technically we're now doing real SSR. So there's a bit of magic that we need to worry about. And again, this is the part that frameworks do for you, because they are easy, they are simple in nature, but they are hard to grok, all things considered. So in the client.js file, I set up a isClient variable and an isFirstRendered variable to determine if I'm running this code on the client or on the server. I set a variable to determine if it's a first render, if that piece of code is running for the very first time on the client. So this is why I have this snippet here. I check if we are on the client and if it's a first render. If it's a first render, we need to hydrate the to-do list data from the server so the app can stay working on the client. So this is a piece of magic the frameworks do for you. If you're rendering a component on the server, like this to-do list, be it React or Vue, you're gonna have a variable that's available on the server and that's used to generate the markup, to render the component. And that can run on the server and you get the markup on the server. If you deliver that markup to the client and you want that JavaScript to stay working on the client, so you can add more stuff and just keep it, maintain it working, you need to have the same data that was available on the server that needs to be available on the client as well. Because the client's going to run the component code to render, and it's going to look for that piece of data and it's not going to find anything. It just has the pre-rendered markup from the server, but it can load the data from that markup. So that's why you need to do data clients. We call this client-side data hydration. So you get the pre-rendered markup and then load the page, and we load the data that's associated with that render so we can keep the app working. So it's really tricky. Of course, this is a really simplified example. In a real app, there would be a lot more to it, but that's essentially what these frameworks are doing for you. And then we have here the add event listeners function, like I mentioned. So some key considerations about this example. Markup is generated by JavaScript. This could be a Vue or JSX template. The HTML list now is always rendered based on the model, on the data, as opposed to having an individual list added every time. So of course, this is not ideal. A full render, the whole block of markup is going to be rendered every time the list is updated. Frameworks in this case, like Vue and React, take care of just updating the snippet of DOM that actually needs to change instead of causing a full re-render. But for educational purposes, I think this illustrates it well. So on page load, no JavaScript needs to run to get the HTML. And that's where you get the improvement in metrics. You just get the HTML ready to be consumed by the browser. And then afterwards, you do that, you do the hydration. You get the data that you need. And then the render function, the same function that we ran on the server, can keep on working on the browser, which means the render function from the client.js module is universal. It is seamlessly shared between client and server. All right, so now things are about to get more interesting, I hope. This was really foundational. I tried to create the simplest possible example to illustrate a lot of the concepts and the building blocks around frameworks, the kind of problems they are solving for us, behind the scenes. So, and this is why SSR frameworks exists. Frameworks take care of also hot reloading, bundling the client code, both for development and production. Frameworks take care of routing and hydration automatically in making your code universally runnable. So do we really need an SSR framework though? So this has been my journey. Like I said, I was a core contributor to Nuxt.js. I worked with Nuxt.js for a long time. But when I realized the size of the stack, the number of underlying dependencies that we needed to get this full-blown framework going, I started looking into ways to find what those building blocks are, these core concepts that I needed to run SSR apps. And I started to try and bring that to the Fastify stack. So there's a way for us to escape the SSR framework route. We can just use Vite for the hot reloading and bundling of code as part of the developer experience. And in the case of routing and hydration and making your code universally runnable, we can take care of that at the application level. We don't have to delegate that to a framework or any arbitrary runtime, because ES modules, they can be bundled in a number of ways for delivery to the client, and we can reuse the same code easily on the server. So JavaScript is isomorphic in nature. So let's get Fastify and Vite playing together. And this is where I do a little technology preview. So this is a little mini, if I may say so, framework built around Fastify and Vite and a number of other underlying Fastify plugins. So Fastify DX is being designed as a fully ejectable framework. You'll be able to run a command like DX eject and you get everything in the project. You don't get tied to it. It's just literally a couple of files that you get in your project. It has simplicity and minimalism in mind. Doesn't introduce an arbitrary new runtime or API. And it focuses on smart, configurable glue code. I like this term glue code because it relates to good I think whenever I see glue code, I think minimalism, good architecture without really trying to over-engineer things, just get individual pieces working together really well. So Fastify DX, it makes it easier to run any Fastify app. And it makes it even easier to integrate with Vite for SSR. So in a nutshell, Fastify DX is a really smart Fastify configurator. Instead of having to have the imperative declarative setup where you instantiate the server, you add stuff to the Fastify server, add routes. With Fastify DX, you get some automation through module exports. So if you're looking to add a bunch of decorators to your app instance, and by decorators, I mean decorated data, this is one of the things Fastify takes care of you, ensuring that any data, any properties that you add to live Node.js servers, they are done in a way that doesn't hurt performance. So basically, you get to export a set of configurable parameters and objects that are used to pre-configure a Fastify instance for you. So instead of having const app equals Fastify and doing all of that setup yourself, Fastify DX gets you a sensible starter setup, and in your server.js file, you just export. You focus on your code. You focus on the things that you need to do instead of all the boilerplate. So it's a lot like Fastify CLI, minus a few features for now. Instead of operating on individual files like Fastify CLI, Fastify DX operates on folders. So you see, it works on full stack applications. It expects to find a server file and a client module in a folder, and that's a Fastify DX app. It will automatically load a Vite configuration file as long as you define a renderer. And this is where it gets really interesting. So There is a DX example available in the repository. You can check it on example/to-do4. It should be, the dependencies should be already installed if you follow the previous steps, and you just do npx dx dev, and you should have a very early stage version of our development server. So I'm gonna go through what's the differences in this example. So we're gonna evolve the third iteration to using Fastify DX with Vue 3 and using Vite to do all the bundling, and we get the bundling, you get SSR, and we get it all that very tightly integrated with a Fastify server in a very minimal constrained way. All right, so in this example, you have the server where we decorate the to-do list, and then we have a default export that takes an object. That object has an app property that's essentially the Fastify server pre-configured for you, and you just add anything you might need. So this is server.js, and it's a magical file for Fastify DX, because Fastify DX expects to find a server.js file or a server module, could be server/index.js. It's going to load that to get your server going. Another file that Fastify DX will expect to find is render.js. So this is a minimal integration layer with Fastify, with Vite, built for Fastify DX through a plugin that I have been working since last year called Fastify Vite. So when you add a rendered file in your project, you just need to set up these 4 properties to get your integration going. So you set up the server entry point for your Vite bundle, you set up the client entry point for your Vite bundle, and you set up a client, a compile index HTML function, and a create and render function. The first will precompile your Vite and index HTML file, because Vite has this requirement of having this index.html file in every project. Of course, that's overridable through configuration, but in general, that's how Vite projects are set up. You have index.html, and then you have all of the JavaScript code that's loaded through that index.html. In this case, it takes that source and turns that into a function based on a template that you can add more stuff to the HTML. We're going to get to that in a bit. And we have the create render function, which is used to create a render function based on the function that creates your client app. So this might be a little confusing at first, but probably will get clearer in the next slide. So the compile index HTML function is what takes the index HTML source and turns that into a templating function. In this case, for this example, I'm using Luke Edwards' lovely templating language, Tempura. You can use anything you want for that. This is just for setting up the index HTML, the shell of your application. So this is what it looks like, setting up that function. This is still part of the render.js file, if you're looking at it now. Just splitting the snippets across multiple slides so I can go over them. And then in the still in the render.js file, we have the create render function. So that this function expects to receive as parameter a create app function that's coming from your Vite client bundle. So that's the function that's going to create the Vue app instance or the React instance. Doesn't matter what framework you use. This is the function that returns another function to do the actual SSR. So you can see here in this is essentially, this is used as a function that's called by a Fastify handler. So you get a Fastify reference, you get the request, the response, the current URL, and the config that you have for Vite. So you create the app, you get a context, you get an app and a router. So this snippet is going to vary a lot depending on the framework that you're using. In this case, we get an instance of the app, we push a URL to the router, this all running on the server, and then we use the Vue server rendered module to take this app instance and generate the markup that we need. So this, in essence, is what we were doing before with Happy Dawn. in the third iteration. But now we're using modern Vue 3. So moving on here, this is the index HTML template. This syntax that you see here is Tempura, the templating engine. So basically you have the script that includes the bootstrap code, and you have the inlined server-side rendered markup that we get from the render to string method. All right, so what else? Now, instead of having that horrific bit of render function, we can actually use Vue for rendering our little app. So this is much better now. In the script section of this component, we have the setup function, and we get the SSR context. We get the to-do list from the SSR context. We set up a few reactive refs. We set up the add item function that's referenced in the template, and that's it. Yeah, I still need to go over a few more files. Thought I was at the end. So other than that, for getting this app to run, you have to have the server entry point. This is what Fastify DX expects. So you export a default function. It's going to include a reference for the create render function that you set up in the other file. And then it's going to use that with a reference to your create app function to generate the render function. So this is the server entry point. And this is the client entry point. So this is the code that runs on the client. After this, the markup has already been generated on the server, you get this on the client. And this is the bootstrap code for the Vue application. This is where the create app function is coming from. I just wanted to go through all these files so you get a full picture of the mechanics that's happening here, because even though this is much simpler to explain than if you were going to try to explain Nuxt.js and Next.js Remix, it's still a lot to go through. So I recommend that if you really want to learn, try to make to see the parallels between the third iteration, this iteration, the concepts that we are replicating, and all of these mechanics that you see here. So this is the create app function. With the imports redacted for brevity. And there we have it. We have a Vue 3 app being server-side rendered to using Fastify DX. It's essentially the same as we've seen before with the third iteration, but there is a catch. So how many people we have here? Okay. So I just wanted to stop for a second and ask if any of you are actually trying to run this right now. Because if you are, you're gonna see an error. If you try to, you're gonna see that error at the outset. And if you try to add an item to that list, it's just not going to work. Because the difference between the third iteration and the fourth iteration is that the third iteration is fully functional. It's actually able to maintain the app running on the client, and this fourth iteration isn't. So there's a problem with this. You can see here that it's trying to get the to-do list on the client, whereas it's only available on the server. So can you debug this? The Vue setup function is called on both the server and the client, but use SSR context can only run on the server. Our Vue component needs to-do list to render. So what's missing here? Can anyone answer? All right. You're going, okay. So I'm going to give you a few hints. Next.js takes care of these automatically through get server-side props. Nuxt.js takes care of these automatically through async data, and Remix takes care of that automatically with use loader data. So the answer is, of course, client-side iteration. The same piece of data that we had on the server, and that's working for the third iteration, we need that available for this example as well. So can you debug this? You could use, like I said, to do tree also takes care of that. You can leverage the compile index HTML function, and you're going to need to tweak the setup function a little. So as we are running out of time, well, we're not quite out of time, but I'm guessing this could make it a little stretchy to finish in time. So I'm gonna go ahead. Is anybody doing this? Because my original intention was to actually stop for 5 minutes and let you guys work around this problem. But if you're just following through the talk and you just want me to keep going, I'll just do that. All right. So how do we debug this? In To-Do 5, there is a solution that you can run and see for yourself if you like. Basically, what we do is we take the original index HTML and we extend that template. So we have inlined the SSR context. And like I said, this is what Nuxt.js does. There is a window dot double underscore Nuxt variable that gets added to window. And that's essentially what it's doing. It's inlining a piece of code, a piece of data in your markup prior to the JavaScript running. So when it runs, it has access to the same data that it had on the server. So if we do that, we are now expecting an extra property here, SSR context in client/index HTML. And in the create render function, we're going to return that SSR context to the template. Don't use JSON string file for this. This is just an example. There are better, safer functions to do this, like devalue and if just look for safe JavaScript serialization if you're actually contemplating doing all of this by hand. So this is what you do. You pass the SSR context, it returns this object to the template, and suddenly you have access to the context on the client. So in our setup function, all we need to do is check if we're running, are we running this on the server? Okay, let's use SSR context. If we're not, let's just grab that from the window object that we inlined. So if you ever used Nuxt.js before, that's essentially what's going on under the hood if you use async data. But all of these details are taken care of for you. All right, moving on. So let's take this final 10 minutes to talk about scaling SSR. So this is, of course, a topic for a whole nother talk. And there's a lot to be covered because it's not just about the server, and it's not just about the general architecture. There's a lot to cover on the framework side of whatever you're choosing in terms of optimization and making sure that the rendering happens as fast as it can. But no matter what framework you choose, SSR is going to be expensive. At scale, it takes a lot of CPU and memory to stay fast. But there are two obvious things that we can do on the application level, on the server level, that I think that are worth considering. And they at least one of them is the go-to solution for many SSR application scaling issues. And the other is not so much so obvious, or it's being ignored by nearly every framework so far. So fallback to CSR would be nice whenever needed. So instead, it would be nice if we have, like Fastify, there's this under pressure module that lets you see if the server, lets you know if the server is under pressure, if you're about to start missing requests because you're using too much CPU and too much memory. So in a situation like that, where SSR is basically consuming your server, it would be nice to say, okay, you're going to stop doing SSR now. Let's just deliver the client-side bundle with the hydration data and let the browser do the rendering. Let's just render an empty div to the client and let the browser continue. So it would be nice to do that, to be able to do that quickly, easily, while still doing SSR. For the majority of the cases, it would be nice to have this fallback. This is something that my other colleague at Nearform, Michele Riva, has been exploring. He's the author of the Real World Next.js book. So he's fond of saying that maybe you don't need SSR. You should avoid SSR if you can to prevent the scaling issues. So another thing that we can do is cache SSR responses. So this is the part that was originally intended to have this practical example. This, like I said, on the matter of caching and SSR, many people go to Redis. It's like Matteo said, it's the get out of jail free card. All right, so can you add fallback to SSR? So if you're going to try this, I'm not going to spoil it, because this should serve as a really enlightening example of working around these concepts and changing what I showed so far. And if I were to stop to let you guys work on it right now, we probably run out of time. But there is an example, to do 6, that gets this done. You can try and make a copy of it, a copy of to do 5, if you want to try and do it yourself. This is available in the repository. So for CSR fallback, a CSR in this case is client-side rendering, right? So for CSR fallback, we still need the server data. So if we have the to-do list on the server and you're not doing SSR, we still need to get a to-do list data to the client, so the client can still do the client-side rendering. So view exports create app and create SSR app functions. The difference between those two functions is that the create SSR app function expects to find pre-rendered markup. So it uses that pre-rendered markup to do the rendering as fast as it can without repeating any of the steps. So to get this working, I changed 3 files: the render.js definition, the index.html template, and the app bootstrap code. And the way that I did that is that if I send CSR has a query string, CSR equals 1 appended to the URL, then it skips SSR and just delivers the client-side code and lets the browser do the rendering. So this is an exercise that you can get through. Another exercise would be adding caching to SSR responses. So you can also start with a copy of to the 5. Fastify has on request and on send hooks that let you capture requests and the responses generated for those requests in a very performant way. So that's something that you can use. You can cache the render function directly. This is what I did, solving the problem. So you're gonna find the solution in example/to-do-7. Don't forget about invalidation. If we are caching a response and you add a new item to the list, we're gonna need to invalidate that cache because you're gonna need to render the to-do list for other users. So to get this done, you need to change 2 files, the rendered and server.js. The solutions, like I said, are available in the repository. And I think I managed to get to my final slide before the 1 hour mark. So I'm just gonna be glad and wrap this up and maybe open a little time for questions if you have. I'm gonna ask you to follow me on Twitter if you want to hear about Fastify DX, anything related to full stack development. I tweet a lot. And I also put together a little mailing list. I'm gonna share it in the chat here. As soon as I manage to get the chat window. Yeah. So I'm setting up this newsletter to post news about Fastify DX when the public beta is going on, is ready. Right now, everything that you see in these examples is good for playing dev mode because the build scripts and the deployment stuff, documentation, that's all work in progress. So subscribe to the newsletter or follow me on Twitter for news. And I'm gonna stop now and give you a few minutes to ask me anything you want. Okay. All right, I think we can wrap up. Maju, are you with us?
Hey, yeah, I definitely am.